analysis, especially from this subject production technology for your AE and AEE TSPSC exam. Okay na? Wait a minute, sorry for the disturbance. Right. So, if we talk about this subject, it is one of the most important subject and most weightage subject for your exam. Right. See, the weightage of the subject from the last few years, that is in 2015, AE and AEE, if you see the questions, for AE exam 26 questions and for AEE exam 40 questions they asked. And for this HMWSSB exam of same 2015, also 40 and 31 questions they asked. So from this you can understand the weightage of the subject. The weightage of the subject, first of all, it is very high. Based on this you can understand. And also the topics under this subject are like metal cutting, machining, metrology, sheet metal operation, metal forming, NC and CNC machines, right? And also some non-traditional machining methods. There are so many topics. Especially for your exam, they will ask you from these topics, they will ask you basic fundamentals. You no need to worry about this subject. Most of you people think that this subject is difficult, highly theoretical, concept oriented like that. But basic standard questions they will ask you from this subject. We'll discuss these questions. Basic standard questions like Taylor's two-life equation. One question directly they'll ask from the metal cutting. Simple basic questions they'll ask you. We'll discuss those questions. So what I am saying, you no need to worry about this subject. We also gave complete information in our ACE online platform, and in ACE Academy we also discussed for our aspirants, and also we are coming to you for some important and concept oriented questions. So the preparation strategy for this subject is a simple one, like you just go through the basic fundamentals of each and every manufacturing process. Like if you take metal forming, in metal forming basic processes are like rolling, extrusion, wire drawing, tube drawing, and forging. So basic things related to rolling you should understand, you should read, you should remember. That is more than enough. Right. In case if you get any doubt related to this subject, you can access with this email address madhushekarv@gmail.com. Right. Okay, now in this session, right, I can't complete all topics, right? It's very difficult to discuss every topic like casting, welding, all these topics. So here I'm here to discuss some of the important production topics. What are those I'm going to discuss today here? Metal cutting, machining, metal forming, sheet metal operation, metrology, and grinding operation. In your syllabus it is also there. Okay, grinding operation, all these things I will discuss. Right. Okay. And see, we will start the questions, important unexpected questions. Now see here, the first question here it is, the tool life is mainly affected by, okay, the tool life is mainly affected by, first one cutting speed, second one cutting force, third one tool life exponent. Okay, here select the correct answer using the quotes given below. 4 options are there. Here if you observe carefully, okay, if you observe carefully from Taylor's tool life equation, from Taylor's tool life equation, from Taylor's two-life equation you can understand, okay, that is velocity Vt power n equal to constant. So the two-life depends on the cutting speed, and also the two-life depends on two-life exponent. See, remember, two-life exponent. Exponent of what? Two-life exponent of tool material or workpiece material? Tell me which one? Exponent of which material? Okay, exponent of tool life, exponent of tool material, exponent of tool material. So 1 and 3 most of you people will think, and also here I am saying that tool life is also depends on the cutting speed, cutting force. Okay, if the cutting force, if it is increases, more applied force if it is increases, tool life is also going to decrease. Right, based on the Taylor tool life equation you are familiar, speed and tool life it is also depends on the cutting force, so that the most appropriate answer for this question is 1, 2 and 3. Remember. The next question, which of the following values of index n is enunciated with the carbide tools when Taylor's two-life equation, Taylor's two-life equation Vt power n. Now listen, one important thing here I will give you. Listen, for high speed steels, HSS steels, the n value is very small, that is varying from 0.02 to like 0.06 or like 0.08 like that. It's a very small value. In case of carbide tools, the value of n is 0.2 to 0.5 approximately. In case of ceramics, ceramic tool materials, ceramics tools, okay, the value of n is 0.5 or 0.6 to 0.8. So in this tool exponent, the Taylor's tool exponent value is very low for high speed steel and very high for ceramic materials. What are the ceramic materials? Diamond is a ceramic material. Carbide cutting tools like silicon carbide, tungsten carbide, these are, okay now. So the correct answer for this question is B. Yes, right. Correct answer for this question is B. Right. So the n value is here 0.2 to 0.5. Next, another question. The purpose of helical grooves in a twist drill is to, the purpose of helical grooves, this is a helical groove, okay na? Okay, why are you providing this helical groove, tell me? Why are you providing this helical groove? For the it acts as a passage of workpiece material after cutting. Okay, it acts as a passage of workpiece material after cutting. That is the main reason. And also it increases the rake angle. It provides the rake angle for cutting purpose. Okay, now so it is not related to stiffness. Don't think that stiffness is going to be improved. Stiffness is going to be decreased. The material loses it. Here it is. Save a material, save a tool material. It is not at all correct. So provide a space for chip removal and provide rake angle for cutting edge. Provide rake angle for cutting edge. Right. So select the correct answer using the quotes given below. So 3 and 4 is the correct answer. So C is the correct answer for this question. Yes, Srinu, you are right. Srinivas, you are also right. Ramu Varma, sir, is it necessary to go with ESC syllabus or only GATE syllabus will be sufficient? See, Ramu Varma, first of all, GATE, ESC and TSPSC, there is no relevant actually. See, GATE syllabus is completely numerical. Those numericals you can able to solve only with the calculator, right? So don't expect the questions from gate level. They won't ask you such a difficulty level. And ESC point of view, if you go through the ESC questions, ESC questions are like sometimes statements questions, sometimes some vague questions they will ask you. For TSPSC point of view, they may not ask that much difficulty level also. In case, if you want to go through the like GATE and ESC, just go through the ESC basic standard questions and the GATE 1 mark questions, you go through that. Those questions you can able to solve without calculator. And syllabus point of view, remember already TSPSC gave a standard syllabus, you just go through that syllabus. You no need to read extra topics other than a TSPSC syllabus, okay na? You just go through that syllabus, you no need to go other syllabus. Okay Ramu? Right. C no? C is the answer, right? Right, okay. Next. Which one of the following processing sequences will be given the best accuracy as well as surface finish? Now, 4 options are given. In all 4 options, drilling is there, rimming is there, some places grinding is there, pouring is there, lapping is there, etc., etc. Now, first of all, we will discuss about these things. What do you mean by drilling? Drilling is nothing but, if this is a workpiece, we are going to make a hole, cylindrical hole, by using this drill bit. If you talk about boring, boring is nothing but we are enlarging the drill hole. Already hole is there. We are just enlarging the diameter of the cylindrical hole. That is boring. And reaming is actually like slightly enlarging the hole. We want to increase slightly 0.5 mm or 1 mm diameter, you want to increase slightly, right? You can go for reaming, right? So here in the question, if you observe carefully, best accuracy and surface finish, right? So drilling is to make a hole, reaming is to make accurate hole, and lapping is to increase the surface finish. Remember, lapping is to increase the surface finish, reaming is best accuracy, drilling is to making a hole. Drilling is making a hole. Okay na? Drilling is making a hole, right? Correct, Mr. Vivek. Vivek, you are correct. Akhil, you are correct. Okay, Ramya, I think you are not correct. Okay, you are not correct. Electroplating here, electroplating is completely different concept here. Okay na? So just go to this, right? Electroplating, by using electroplating, what we are doing, we are arranging the atoms or layer of material on a particular electrode. Let us say there are 2 electrodes. If we keep these 2 electrodes on electrolyte, and if we connect electric terminals with the battery, the electrons move from cathode to the anode. The material layer is formed on the surface of one particular electrode. That is electroplating. Okay, so it's not like that. You will not get a good surface finish from that, because the accumulation of atoms are not much uniform. Okay, so the correct answer for this, drilling, reaming and lapping. See this diagram, right? Next, in a tool life test, doubling the cutting speed reduces the tool life to 1/4 of the original. The Taylor's tool life index is, now listen, it's a very simple question. See here, Taylor's tool life equation is Vt power n equal to constant, right? So in the question, they are asking that the cutting speed, the tool life, doubling the cutting speed, let us say V2 equal to 2V1, they are doubling the speed. Then by increasing the speed, the tool life is going to be reduced to T2 equal to, okay, T1 by 4 is 1/4 of the original, so T1 by 4. So this is the data given. So from this, Vt power n, V1 T1 power n equal to V2 T2 power n, right? So V1 T1 power n is equal to 2V1 into T2 equal to T1 by 4 whole power n, right? Now we can write it as V1 T1 power n is equal to 2 into 2 by 4 by n that is equal to V1 T1 power n. This is cancelled out. So 4 power n is equal to 2. 2 power 2n equal to 2 power 1. So 2n equal to 1, n equal to 1 by 2. Right. Have you got? Seenu, you are right. Okay. Have you got the answer? Okay, now it's a very simple basic question. Calculator is not required. Like this model, they will ask you question. Like this model, they will ask you question. Don't expect gate level question. They won't ask you gate level question. Basic standard questions. Without calculator, you can solve with basic mathematical formulas. So, answer here it is 1 by 2. Answer here it is 1 by 2. Yes, correct. Vivek. Okay, na? Right. Now, the next question. In the grinding wheel of A60, G7, B23, right? A60, G7, B23, B stands for. See, this is the representation of a grinding wheel actually. This is the representation of a grinding wheel. Here, what this B represent? First of all, I'll give you clarity about this. Let us consider an ISO designation of a grinding wheel. An ISO designation of a grinding wheel is like this. Here, the first and last will give you the information about the grinding wheel given by the manufacturer. So, you no need to remember that actually. Only these 5 things you should remember. These 5 things you should remember. What did this first represent? The first one represent type of abrasive. Okay, remember the first one represent the type of abrasive. If C letter is there, that represent carbide abrasive material is used. Then A represent aluminum oxide, D represent diamond. Okay, either C, A or D they will use here symbols. Next, the second one number is 30. 30 represent a grain size. Now here 10 to 24 grain size roughness is more, 30 to 60 medium, 70 to 180 finishing, 220 to 600 super finishing operation, highly smooth surface finish will get. So in the question it is given, see that we will discuss later. So here based on this example, okay, 30 is given, 30 is medium, grain size is medium. Next, letter M, third one, letter M represent hardness. Let us, third one represent hardness. A alphabets A to Z it is there, A to H represent soft, I to P represent medium, Q to Z represent hard. In this example, M is given, M represent medium hard wheel. Medium hard wheel. Next, another letter, another number, that is 5, fourth one. 5 represent, what it represent? It represent, fourth one represent a structure. 0, dense structure. 16, open structure. So it is given the number 0 to 8, 16. So 8 is given, it's a medium dense structure or medium open structure like that. So the last one, V, what it represent actually? V represent a type of bond. Here the fifth one represent a type of bond. Here V represent a vitrified bond, silicate bond, S represent silicate bond, B represent resinoid bond by using thermosetting materials, okay, and R represent rubber, M represent metallic bond. Now let us check the question. The question here it is, in a grinding wheel, the B stands for, B stands for. Now tell me, everyone, Srinivas D, Vivek B, Naresh A. Now tell me, what is the answer? What is the answer? B represent. B represent, tell me what is the answer? Akhil, you are right. Because B represent resinoid bond. Now see here, B represent a resinoid bond. So in this question they are asking B. B represent a resinoid bond. B represent a resinoid bond. Now clearly understand, this is also very important. That's why I am explaining all these things. Okay na? very, very important. That's why I am explaining all these things. Next one, listen. Consider the following steps involving in hammer forging of a connecting rod. So we are going to make a connecting rod by using hammer forging or hand forging, like that, basic secondary forging operations. So first of all, what is forging? Now you can see this is a connecting rod here. Actually, this is a connecting rod. We are going to make this connecting rod, okay, we are going to make this connecting rod by using a forging operation. In case of forging operation, we are keeping a workpiece material between two dies and we are pressing, we are compressing, we are applying compressive force. So initially, if it is a billet material, initially you have a workpiece material like that. Then first you should increase the length, decrease the cross section area and increase the length. So if you want to increase the length, you should go for pullering. So pullering is what? Increasing length and decreasing cross sectional area, right? Pullering. After increasing the length, okay, you want to make this section, right? To make this section, we should localize the material. We should bring some large amount of material at this location. That we call it as edging otherwise. So localized collection of material, localized collection of material, edging or edgering, localized collection of material. Pullering is increasing the length and decreasing cross sectional area. Edging means localized collection of material. After making a localized collection of material, what we are doing? We are keeping this workpiece in between die which are having impressions of this connecting rod. We will keep that and we will apply the force, so that you will get like this. That is known as blocking. So blocking is nothing but, okay, making near net shape of component, making near net shape of component, making near net shape of component, okay, making near net shape of component. After blocking, we are making finishing, after that trimming. So 4 5 1 1 3 2, 4 5 1 3 2. So 4 5 1 3 2, B is the correct answer. This question asked in many competitive exams, that's why I am giving. Okay, na? Many competitive exams they asked, that's why I am giving this question. Correct, B is the correct one. Right, okay. Next, another question. A brass billet is to be extruded from its initial diameter of 100 mm to a final diameter of 50 mm. The working temperature of 100 degrees Celsius and the extrusion constant is 250 megapascal. Then the ram pressure required for the extrusion process. See, it's a very simple question. See, first of all, here ideal extrusion process if I consider, ram pressure is equal to mean flow strength of the material, sigma m ln, okay, A naught by A1. This is the formula. So in the question, the extrusion constant is given at a temperature of 100 degrees Celsius, that is 250. So ram pressure is equal to 250 into ln A naught by A1, that is 100 by 100 is a diameter, okay na? I can write it as D naught by D1 whole square. D naught by D1 whole square I can write. So 100 by 50 whole square, that I can write 250 ln, this is 2, 4 you can write. So if you see the answers, okay, the first answer is the correct one. First option is the correct one. Option A is the correct option. Right? Correct, Vivek? Vivek? You are not correct. Bharat, correct. Now clearly understand? Okay? It's a very simple question. I said in the class also, I said in the online also, you should remember in case of metal forming like rolling, extrusion, forging, wide drawing, tube drawing, you should remember ideal metal forming operation formulas like especially force and pressure formulas. Ideal metal forming, ideal rolling force, ideal extrusion pressure, ideal wide drawing force, ideal wide drawing pressure. These formulas you should remember because calculator is not allowed, so that they will ask you basic ideal formula related numericals. So you no need to use calculator here because in terms of ln only answer is given. This type of questions also they will ask you for your exam. Okay, na? Especially this type of questions will ask from metal forming. Okay, especially from rolling, forging, extrusion, all these. Okay, from these areas. Right. Okay, na? Next. Another question. In the blanking operation to produce a steel washer, the maximum punch load used is 2 into 10 power 5 newtons. The plate thickness is 5 mm and percentage penetration is 20%. The work done during the shearing operation. So this is actually blanking operation, punching and blanking operation. So very important formula is there in punching and blanking operation, that is F max is equal to sheared area, that is pi dt into tau u. This is very important. Sheared area into shear strength, and work done is equal to F max into PT. Right. It's a very important formula. Now in the question, the maximum punching force is given 2 into 10 power 5 newtons. Right. Now is it okay? Am I audible and visible? There was some technical issue, that's why it was interrupted. Some error it was there, but now okay. Am I audible now? I hope I am audible, right? Right. Now, okay, everyone, Akhil, Vivek, Sinu, Chari, Khalil, right. Shall I explain this question once again? See, in this question, what they asked, blanking operation is given in the question, and the maximum punch load is given 2 into 10 power 5 Newton. The plate thickness is 5 mm is given. The percentage of penetration is 20%. The work done during this operation. As said, in the punching and blanking operation, you should remember these two formulas. These two formulas are very, very important. They will ask you questions directly. Okay, without calculator you can solve. That's why they will ask you for state service exams. But in the question, already force is given. They are asking work done. So work done is equal to force into penetration thickness, right? Here force is, this is 2 into 10 power 5 Newton is given. Penetration is 0.2, 5 mm thick, 5 mm is given. That's why I'm converting into meter, 5 into 10 power minus 3. So I'll get this answer. I hope everyone understand this question. 200 joules you got. Yes, 200 joules you got. Okay, 200 joules. Is it okay? Right, it's a very simple question. Now I'm moving to the next question. Right, now listen. A metallic disc of 20 mm diameter is to be punched from a sheet of 2 mm thickness. The punch and die clearance, this is also very, very important. Design of punch and die, they will ask you questions. Okay, design of punch and die, they will ask you questions. Listen, in case of punching operation, once again I will recall the formulas. In case of punching operation, remember punch size is equal to hole size. Punch size is equal to hole size. Die size is equal to punch size plus 2 into clearance, in case if it is a radial clearance. In case if it is a diametrical clearance, punch size plus clearance. In case of blanking operation, remember, okay, die size is equal to blank size. Die size is equal to blank size, okay, or a coin size. Punch size is die size minus 2 into clearance. So remember, in case of punching, okay, clearance is provided on die. In case of blanking, clearance is provided on punch. Very, very, very important. In case of punching, clearance is provided on die. In case of blanking, clearance is provided on punch. Right. So in the question, metallic disc of 20 mm diameter. See, remember. So tell me, what is this operation? What is this operation? It's a blanking operation. We are making metallic disc, right? Blanking operation. If it is a blanking operation, okay, thickness is given 2 mm, die and punch and die clearance is 3% given. Here they didn't mention is it radial or diametrical. Mostly radial only they'll give, so you should remember it as a radial. You should consider it as a radial. Otherwise we'll check the options. So punch diameter. So remember, in case of this blanking operation, die size is equal to 20 mm. Punch size is equal to 20 minus 2 into 3% of thickness, that means 0.03 into thickness 2 mm, right. So you will get 20 minus, okay, you will get from this 0.06 and from this you will get 0.12. So 0.12, if you take it, 19.88 mm. 19.88 mm, this answer you will get. Is it right, everyone? Vivek, Sinu, have you got the answer? Have you got? It's a very simple and important topic for your exam. They will ask you questions from this model. Okay, na? Be careful regarding this. Next question. The bending force required for V bending, U bending and edge bending will be in the ratio of, this is also very, very important. Okay, in case of edge bending, very less amount of force is required. In case of V bending, some force, somewhat good amount of force is required. But in case of U bending, more force is required. Why? Why U bending more force is required? Because the sheet has to move into the deep cavity. That's why more force is required in case of U bending compared to V bending, compared to edge bending. Generally, edge bending, if it is required 0.5, then V bending 1, then U bending 2. Right. Now, in the question it is given in a different manner. You should be careful about that. First is given V bending, second is given U bending, third is given V bending 1, okay, 2.5. So 1, 2.5. So A is the answer for this question. A is the answer for this question. Bharat BCA. That's why Bharat, you should be careful about this. Very, very important. Edge bending require very, very low force, then V bending, then U bending. U bending require more force. So in the question, U bending is the last. Sorry. Right. Wait, I'm confusing here. Options are not correct, right? 1, 2, oh, right, correct. Answer is A for this question, correct. Vivek, you are not correct, C. C, remember, V bending 1, U bending 2, edge bending 0.5. A is the correct answer for this question, correct. I confused. Next question. What is the bend allowance in the following figure if the bend radius is 100 mm? This is also very, very important. Remember, bend allowance formula I will give you. You should remember this bend allowance formula. Bend allowance, that is equal to R plus K into T into alpha. In case if it is alpha is given in terms of degrees, you should convert that into radians, that by multiplying with pi by 180. Right. Here K is a stretch factor. K is stretch factor. In the question they will give you. In case if in the question if it is not given, K you can take it as a 0.5 mostly. Okay, 0.5, that is 1 by 2. Sometimes K is given 1 by 3 also. In case if K is given 1 by 3, in case if radius of the bend is less than 2t, then you should take this one. If radius of bend is greater than 2t, then you should take this one. But you no need to remember, at least you remember K equal to 1 by 2. This is a formula, very, very important formula. Bend allowance questions, they will ask you questions. Okay, so in the question, bend radius is given 100. Bend radius is given 100. K equal to 1 by 2, you should remember that one. And the thickness is 2 mm. So 1 by 2 into 2 into 1 radian is given in the question. Bend angle is given 1 radian. 1 radian is given. So answer will get 101. Straight answer will get, no need of calculator. This type of questions they'll ask you. One more question I'll discuss, no need to worry regarding this. Okay, na? 101 you'll get the answer. Answer is C. Answer is C. You're getting? So they'll ask you questions from this bending operation, especially calculate bend allowance, or otherwise energy or force is required in the bending operation. Right. Next, another question. Match the correct combination for the following metal working processes. In the list 1, they are given processes, and in the list 2, associated state of stress, associated state of stress, okay, associated state of stress, blanking, stretch forming, coining, deep drawing. Okay, now, so first of all, blanking is nothing but it's a shear cut operation. We are cutting the sheet metal to make a blank. So blanking is P is 3 shear. So sort out, see, if you know one thing, if you know like blanking shear, so first eliminate the options. That is the best way to solve the question. See, P is 2 given, so this is not correct. P is 5 is given, this is not correct. So P is 3, correct. So B and D are the answers. Next, check it. Stretch forming is nothing but bending the sheet metal like that, okay, bending the sheet metal. So tension is going to be formed, right? Stretch forming, tension, and also sometimes if let us take if I bend the material like this, some areas tension, some areas compression, like that, okay. And a coining is nothing but a compression. Deep drawing, tension and compression. Remember, first clarity I'll give you, deep drawing means we are keeping the sheet metal on a die and we are applying punching force. So tension and compression both are going to be generated. So let us say S is 2. S is 2 is not there, okay, S is 2 is not there, sorry, S is not 2, S is not 2 here, S is tension and compression, right? See, S is tension and compression, S is 4. Now see here, if here S is 5, not correct, because shear is not there in the deep drawing, we are not cutting the sheet metal. So tension and compression is there, so D is the correct answer. So stretch forming, tension, coining is nothing but a compression. So easy to get the answer for this question. So D is the answer for this question. Sometimes like this match the following questions also they will ask you for your exam. Next, another question. During the sheet metal operations, the spring back is caused because of what? The spring back effect is caused because of what? Let us say a sheet is there, you are bending the sheet up to certain angle, you are bending the sheet metal up to certain angle, after that you are releasing the load. Once if you release the load, it will regain back, okay, some bending angle is going to be decreased, right, it will regain back. What is the reason? The reason is there is an elastic deformation in the material, sheet material, that elastic deformation is going to be recovered. That elastic recovery is nothing but, okay, elastic recovery is nothing but spring back effect. Now, if you see the options here, first option, release of the stored energy during the elastic and plastic, no, only elastic deformation is correct. Release of stored energy during the plastic, no, correct. Release of stored energy during the elastic, correct. Excess energy that was utilized during the forming operation, so C is the correct one. Simple question. C is the correct answer for this question. C is the correct answer for this question, right? During the sheet metal operation, the spring back is caused because of release of stored energy during the elastic deformation, right? Next, match the deformation process in column 1 with the corresponding stress states listed in the column 2 and select the correct answer from the quotes given below. So we already discussed this one, okay, once again we will discuss this one. Forcing operation, direct compressive force you are applying here, forcing operation, direct compressive force you are applying. Stretch forming is tension, directly tension. Wide drawing, indirect compression, and cutting is nothing but shear. So 2, 1, 3, 4, 2, 1, 3, 4, 2, 1, 3, 4, C is the correct answer for this question. See, remember, wide drawing, indirect compression, because we are applying a tensile force, directly we are applying tensile force because die is in converging shape, so that indirect compressive stresses are applied. And forcing operation, we are applying a direct compressive force, we are keeping the workpiece material between the two dies and we are applying force. Stretch forming, tension, cutting, shear. Okay, now? Next, another question. A 30 mm thickness tube is drawn by tube drawing operation to reduce its thickness up to 20 mm. The mean flow strength of material is 300. Then the ideal drawing stress, I said na, you should remember the formulas related to ideal drawing stress and ideal drawing force of wide drawing, extrusion, all these things. right? So the formula for drawing stress, in case of wire drawing or a tube drawing, remember it's a tube drawing operation. So in case of tube drawing operation, we are reducing the thickness of a tube. We are reducing the thickness of already existed tube. So thickness we are reducing. So tube drawing process, if I take sigma d is equal to sigma m ln h naught by h1. See, previously in the extrusion case, sigma m ln a naught by a1 we took, but here h naught by h1. We are reducing the thickness of the sheet, so that in the question mean flow strength is given 300 into ln, how much? 30 mm thickness is reduced to 20 mm, 30 by 20, that is 300 ln 1.5, 300 ln 1.5. So A is the correct answer for this question. Okay, A is the correct answer for this question. Now getting everyone, Vivek, Seenu, getting everyone? H naught by H1, H naught by H1, okay, 30 by 30 by 20, 300 ln 30 by 20. Next, another question, okay, another question. Now see here, during a blanking operation of a mild steel sheet, if a diameter of blank is increased by 30%, remember it's a blanking operation, okay, blanking operation, blank size is increased by 30%, sorry, diameter of the blank is increased by 30%, thickness is reduced by 6%, then the required percentage increase in punching force. Now see here, general formula F max, that is equal to pi dt tau u. Material is not changing, same shear strength, only diameter we are changing. Let us say d2 equal to 30 times 30% increased, so 1.3 d1, d2 equal to 1.3 d1, and t2 is equal to how much? T2 6% reduced, so 0.94 into t1, 0.94 into t1. Now see here, F1 max, that is equal to pi d1 t1 tau u, F2 max, that is equal to pi into 1.3 d1 into 0.94 t1 into tau u. Now that is F1 max into 1.3 into 0.94. So you should multiply this one. Very simple, no calculator. Calculator is not required. Most of you people think that it's a complex question. It's a very simple question. Formula if you know, you will get the answer. F1 max is equal to pi d1 t1 tau u. F2 max equal to pi d2 t2 tau u. Pi d2 equal to 1.3 d1. T2 is equal to 0.94 t1. 6% reduced, 0.94. Right. So now from this, if you multiply this, you will get approximately 1.22, something like that you will get. So 22% is increased. 22% is increased here. Right. This is the correct answer. It's a very simple question. Next, another question. Here also bending allowance they are asking. See here, a 6 mm thick metal sheet, 6 mm thick metal sheet is to be bent at an angle of 1 radian with a bend radius of 130 mm. Stretch factor is given in the question. So I said bend allowance formula, simple question. This is bend allowance is equal to R plus KT into alpha. If I take R is 130 into R equal to 130 R equal to 130 plus plus k equal to 0.6, 0.6, k equal to 0.6 into 6 mm into 1 degree radian. Okay, 1 degree radian, right? So 130 plus 0.6 into 6, 3.6, 36, you will get 6 by 6, 36, 1.3.6, so 133.6 mm is the answer. So B is the correct answer for this question. Like this type of questions, basic standard questions they will ask you from this. Basic bend allowance questions like this, basic standard questions they will ask you from this. Next, here same formula I am not explaining, this is the same formula, maximum punching force pi dt tau u. Here I am not going to discuss here because I already discussed so many questions. Here 22 by 7 I am writing, and diameter 7, thickness is 3, and shear strength is 350. This is cancel out. So by multiplying 22 into 3 into 350, you will get the answer in terms of kilonewtons that I am not discussing. You will get D is the answer. Okay, right. Now, next another question. A forcing method of reducing the diameter of the bar and the process it make it longer is termed as. See, it's a very simple. In a forcing operation, we are reducing the diameter and increasing the length. That's nothing but a pullering operation. So remember, in case of pullering, we are increasing the length, decreasing the diameter. In case of punching, we are making a hole. In case of upsetting, we are increasing the area, decreasing the length. Upsetting means increasing the area, decreasing the length. Extrusion means we are reducing the cross-sectional area of the rod by applying compressive force. So pullering is the best answer, correct answer for this question. Next, which one of the following is an advantage of forcing? See, forcing operation main advantage is we can make a complex shapes and we can improve the properties of material. So D is the correct answer for this question. We can improve the properties of material by using forcing operation. That is the best option for this question. Now, deformation given below metal alloy is considered as a hot working operation. See, remember another important thing. Lead and tin alloys recrystallization temperature is less than room temperature. That's why lead and tin alloys recrystallization temperature is less than room temperature. That's why these alloys are going to be considered as a hot working operations at room temperature. The metal extrusion process is generally used for produce uniform solid and hollow cross-sectional components. We can make solid and hollow cross-sectional components by using this process, right? Cold working, in case of cold working, grain structure is distorted. Okay, grain structure is distorted, smooth surface finish you will get. Okay, grain structure is distorted, and stresses are also going to be set up, residual stresses are also going to be set up in the operation, right? Strength and hardness is decreased, finishing, surface finishing is good. Out of these two, the most effective answer you will get, a grain structure is get distorted. Now, let us consider another question. A workpiece revolves by 500 RPM and there is a charter mark at a spacing of 30 degrees. Find the charter frequency. Now, charter mark is spacing at 30 degrees. In one revolution, 360 degrees. In case of 360 degrees, for every 30 degrees there is a charter mark. So, in one revolution, 12 charter marks are there. 12 charter marks are there in one revolution. Like that, there are 500 revolutions given. So, for 500 revolutions, how many charter marks here we are going to get? 12 into 500, that is 6000 charter marks. Revolution per minute, in a minute. So, by 60, you will get 100 frequency per second, charter marks per second, 100 you will get. So, the correct answer for this question is B. Correct answer for this question is B. Next, The headstock of lathe has 9 speeds of ranging from 100 to 1600 rpm. The ratio between two consecutive spindle speeds. Now, here you should remember one important formula, that is N max speed ratio, maximum to minimum speed ratio follows geometric mean r power n minus 1. Here N max is 1600, N minimum is 100, that is equal to r power 9 speeds, 9 minus 1, so r power 8. So r equal to, okay, 16 power 1 by 8. That is 16 means 2 power 4, 1 by 8, that is 2 power 1 by 8, that is root 2, that is 1.414. That is 1.414. So the correct answer for this question is B. It's a simple, but you should remember this formula. Sometimes, okay, without calculator you can solve this type of questions. As an engineer, you should remember root 2. You should remember 1.414 root 2 value. Right, this is the answer for this question. Next, the method of producing large diameter holes without drilling complete material which is not converted into chips. See, based on the options you can understand, there are 4 options, leave it. Now see here, this is the correct one. Now this is a workpiece material. Okay, by using the small tools, we are making a hollow, we are cutting a small portion of the material and we are removing this portion of the material. Right. So trepanning is the correct answer for this question. So B is the correct answer. Okay. Method of producing large diameter of holes without drilling complete material, that is trepanning. Okay. Counter boring means enlarging the hole. Counter sinking means making tapered section of holes. Okay. Now what symbol is used to indicate the surface roughness? The surface roughness symbol, this one. Surface roughness symbol is this one. Now you can see the symbol used in this case, single reverse triangle is there. This is the central level average mean value is there 8 to 25 micrometer. So 2 reverse triangle, this is the value, 3 triangles. So 4 and 5, increasing the reverse triangles, these symbols, if we increasing, the surface roughness is very, very low, surface finish is very, very high. Next, which of the following given the correct order of increasing hardness of cutting tool material? So increasing hardness of cutting tool, high speed steel, silicon carbide and diamond. Diamond is the hardest one. So the last, increasing order they are asking. Increasing order, the diamond is the last one. It is the hardest. Steel is the least. Silicon carbide is, let us say the hardness value. The diamond is 8000. Silicon carbide approximately 2500. This is hardly 100. Imagine such a high hardness, this silicon carbide and diamond. So C is the correct answer for this question. Now continuous chips during the machining form when? See, if you want to get a continuous chip, it should be a ductile material. It should be a ductile material. Speed is high, feed is low. If feed is high, it will break. Feed is low. The depth of feed should be low. Speed is high. It should be a ductile material. Good surface finish is also required. So this is, the speed is high and feed is low. A is the correct answer for this question. Next, in metal cutting, use of low feed and high cutting speeds is decided when objective is actually to get a good surface finish. Listen, if you want to get a high material removal rate, the feed should be high, right? The feed should be high. So if you want to get a smooth surface finish, the feed should be low and high speed is required, right? And climb milling is a non-conventional milling operation. It's a down milling. What do you mean by climb milling? Here I'll get to know. Listen carefully. In case of climb milling, this is a climb milling. In case of climb milling, the cutter is moving in this direction, feed is also moving in this direction. So initially the cutter will cut maximum feed, at finally very less feed. Depth of cut is more at initial, depth of cut is less at the end. But in case of conventional milling, up milling, okay, they are in opposite. They are in opposite. Initially less, material removal, at a final more material removal, right? So in case of up milling, in case of down milling, more surface roughness you will get, initially more material removal rate, finally more less material removal rate. Now see here, chip thickness increases gradually, not correct. In case of clay milling, chip thickness is more at initial and less at final. Next, enables the cutter to dig in end start of the cut. See here, end start of the cut. See, in case of this milling, conventional milling, at end point there is more dig into that. But here at initial stage only it is going to cut. So this is not correct. The specific power consumption is not going to be reduced. Better surface finish can be obtained. Okay, na? The surface finish is good. Better surface finish you will get in case of this, right? Negative rake angle in cutting tool is mainly used for brittle material by providing negative rake angle. See, by providing negative rake angle, strength increases, tool life increases, but power required in the operation is not going to be decreased. So 1 and 2 are the correct answer for this question. The type of pit considered when lower limit of hole is larger than the upper limit of hole, that is a clearance fit. See here, the lower limit of hole, this is larger than the upper limit of the shaft. So the clearance is present, minimum clearance is there. So it's simply a clearance fit. It's a clearance fit, right? The straightness is a deviation of surface from the ideal straight line. The straightness can be measured by altocollimeter, spirit level and straight edge. So all these three are used to measure the straightness. All these three are used to measure the straightness. Which of the given below surface lay produced by nulling operation? Remember, nulling operation. See here, different shapes, symbols and description. See, parallel lay is used for shaping of planing operation, parallel lay, cutting the material like this. And shaping and planing produced by, surface is produced by shaping and planing. Here also the perpendicular lines are produced or parallel lines are produced. But cross lay, this is a cross lay, knurling operation, cross lay. In case of multi-directional grinding operation, you will get multi-directional. And for facing operation, you will get a circular lay. For facing, this is a shaft material is cutting like that. And radial lay is also same facing operation you will get. So in case of knurling operation, you will get the crossed lay. You will get the crossed lay. So C is the correct answer for this question. Alligatory defect is commonly observed in rolling operation. Alligatory defect is what? It is nothing but separation of two pieces of rolled workpiece material like this. Okay, like that. This is alligatory defect. Alligatory is nothing but a crocodile. Alligatory defect. Alligator is nothing but a crocodile defect. Alligator is nothing but a crocodile. So crocodile will open the mouth like this. So in a rolling operation, because of non-uniform deformation of the material, because of non-uniform speeds of the rollers, the sheet at the center of the sheet, in case if there is any defects, in case if there is any impurities, it will deviate like this. So that's why it will deform, it will separate the sheet into two pieces. They are separated like this, that is alligatory defect, right? The coefficient of friction between the roll and slab is 0.2 and the roll diameter is 200 mm. The maximum possible reduction. Remember, in the rolling operation, delta H max, that is equal to mu square R, very important. So they are asking maximum possible reduction. Maximum possible reduction, that is nothing but delta H max, that is equal to mu square R. Mu is 0.2 whole square into, its a diameter is 200 given, so into 100. So you will get 100 into 0.2, 0.2 into whole power 0.04, so 4 you will get the answer. A is the correct answer for this question, right? And the last one, which of the following die used to produce more than one cutting operation in one stroke at different stages? Remember, more than one cutting operation in one stroke at a different stage. And also punching is the first operation, blanking is the last operation, that is a transfer die. Sorry, that is a progressive die. In case of progressive die, different stages it is performed in one stroke, but punching is the first, blanking is the last. But transfer die, blanking is the first operation, punching is the last operation. So both are same only, minor difference is, in case of progressive die, punching is the first operation, blanking is the last operation. In case of transfer die, blanking is the first operation, punching is the last operation. Compound die means what? You know, compound die means like more than one cutting operation is performed in one stage at a time, both blank and blanking and punching takes place. Watch, you will get. Here multiple die, combination of all these things like metal forming, metal cutting, sheet metal operation, like sheet metal forming, sheet metal drawing, that is a multiple die. So the correct answer for this question is B, progressive die. So these are the some of the questions I discussed within this small time. Like that, you should prepare each and every production process, right? And all the best for you. Thanks for listening patiently. And if you get any doubt, I already gave my mail address at the first, so you can approach me through mail, right? All the best for your exam. Thank you.